Hi everyone, let's skip straight to example 2, where we roll one die. That random experiment, rolling one die, a standard 6-sided die. Now if X is the result, the die face we get when we roll a standard 6-sided die, then it turns out that E of X, or mu, the expected value of X, or the mean of this distribution, turns out to be 3.5, and we'll see why. Now, first off, this is the probability distribution table for X. It should look familiar. These are the 6 possible values of X, the integers from 1 to 6, and each of the probabilities is 1/6. The probabilities are all equal. This is called a uniform distribution. These are all equal. Now, because the distribution is uniform, because the probabilities here are all equal, actually E of X is just the straight up average of the die faces. So the naive approach does work. The expected value of X, or mu, is given by the following fraction. We add up the various possible values of X, 1 plus 2 plus 3 plus 4 plus 5 plus 6. And we divide all of that by 6, the number of values. So when you do that, when you take the straight up average of these 6 values over here, the integers from 1 to 6, you end up with 3.5, which makes sense because you look at these integers from 1 through 6, 3.5 seems to be right smack dab in the middle. So it makes sense that the straight average is 3.5. So the expected value of this random variable X, remember we haven't rolled the die yet, it's a random variable. The expected value of this random variable X, or the mean of this probability distribution for X, is 3.5. Well, so what? So what? I mean, don't you agree that if you roll a die, it could come up a 1, as well as a 2, as well as a 3, as well as a 4, as well as a 5, as well as a 6. What does the 3.5 really tell us? It tells us a long-run average. So here's the interpretation. Here is the interpretation of E of X, the expected value of X. The interpretation is that if the die is rolled many times, like let's say 1,000,000 times, you have no life, you take this die, you roll it 1,000,000 times. Okay, maybe you're a total gambling addict. If the die is rolled many times, then the long run average, of the die faces will be about 3.5. So if the die is rolled like 1,000,000 times, then the average of the die faces will be pretty close to 3.5, we would think. So again, here's the idea. Let's say that you really have no life and you roll a die 1,000,000 times. Maybe you get a 1 on the first roll, a 4 on the next roll, a 2 on the next roll, another 2, let's say, a 5, a 3, a 6, and so forth. If you roll this die 1,000,000 times, all right, if you take this sum of 1,000,000 die results, and if you divide it by 1,000,000, okay, again, we've rolled this die 1,000,000 times. Roll the die 1,000,000 times. You get these 1,000,000 die results, add them up, divide by 1,000,000, and the result should be very close to 3.5. We'll talk about these issues later on in the course. So that's the idea. The expected value of x, or the mean of the distribution, can be interpreted as a long-run average. The average we would expect if we were to repeat this experiment, in this case rolling the die, many, many times, like 1,000,000 times.